Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafi anbiya'i wa mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrahli sadri wa yassirli amri wa hlul 'uqdatam min lisani yafqahu qawli. Allahumma aftah alaina hikmataka wanshur alaina min hazaini rahmatika ya arhamar rahimin. Sallallahu ala Sayyidina Muhammad wa ala alihi wa sahbihi wa sallam walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Thank you to the organizing committee of CFORS to organizing this conference. Today, I would like to talk about forensic age estimation in Malaysia, a geometric morphometric study of mandible using CT scan. As we know, forensic anthropology is a field of study which focuses on examination of human bones systematically in order to get identification of remains in medical legal case. We have 206 bones in our body, but I want to tell you about one bone that we call mandible. In case of mass disaster such as tsunami where the remains were massive, the process of identification became complex and difficult. Recent research focused on various skeletal remains to quantify the variation related to sex, age, and race to facilitate forensic identifications. A great deal of research was conducted to identify the shape and the pattern of mandible in human body. In some cases, the method was able to describe the size, but not to explain the bone shape quantitatively. So besides, no study yet quantified the morphology of mandible comprehensively for identification purposes in Malaysian population. So my objective is to evaluate mandible size and shape and its variations in adult Malaysian by 3D geometric morphometric. And in this research, I want to determine the difference variation of the mandible among different age groups that we divide into 3 groups, young, adult, middle adult, and elderly. In our study, 447 mandibles were divided into 3 groups, Malay, Chinese, and Indians. And edentulous damaged mandibles and foreigner were excluded, by adult, intact mandible, and Malaysian were included in this study. And then what we did is we did a geometric morphometry analysis. And lastly, we get a shape of the mandible and its variation. First step is we put the lemma application using the Stratovan checkpoint, and then we do analysis of the geometric morphometric using few software, Morphometric, PASS, and also SPSS. And then we analyze with the general processes analysis, principal component analysis, discriminant function analysis, canonical variant analysis, processes ANOVA, MANOVA, and also t-test. Lastly, we come with the visualizations of the mandible. And lastly, we have a sex, age, and age, but in this time, we focus on age. Firstly, 24 landmarks were applied to the mandible, namely genation, Pogonians, mandibular symphysis, infradental, premolar, molar, third molar, anterior ramus, coronal process, mandibular notch, condylar process, posterior ramus. So both sides are 4 in the middle, and at the 20 remarks 10 on the right and 10 on the left. Lastly, angle of the mandible and mental foramen. So step 2, what we did is we did a general processes analysis to remove translation, rotation, and scaling, and we come up with the centroid size. So in the generalized processes analysis, size, location, orientation was removed. And then the blue dots represent the main lemma of the positions, and the small dots represent 447 data. In the principal component analysis, we found that there is a 34 variation of the mandible in the Malaysian populations, with the three PC accumulate the highest percentage of the shape of the mandible. And the three principal component analysis explain the variation in shape of mandible around 40%. So this is the changes, the highest changes shape variation in Malaysian population PC1. We found there is a highest variation in the body, in the ramus of mandible, and also body of the mandible. This is a mean. This is the most positive changes, and this is the most negative changes in the PC1. And this is the mean share of the groups of the male and female, Malay, Chinese, and Indians. And this is a middle, young, and elderly shape of the Malaysian population. So we did a MANOVA. We found that there's a significantly difference in ancestry. And after postdoc, we can see the highest percentage of the benforated current p-value was seen in the Indians and also Chinese. So from the age, there is also a significantly difference, and with there is a significantly difference between young and middle, and young and also elderly. Sex also have differences between male and female. When we did processes ANOVA, we found that there is no age differences effects on size, but in the shape we can there's a significant difference in the age shape. This is ancestry. We can see that there is a significant difference between Malay, Chinese, and Indian, with the Malay in the center and Indian in the left and right side, with the highest significance from between Indian and Chinese shape. For the age, we can see that there is a significant difference between young and middle and groups, and also young and also elderly group. The young age group is between 18 to 40, while the middle age is 41 to 60, while elderly is 61 is to 87%, 87 years. So after we do the processes permutation, also you can see there's significant difference between the groups, between young and middle, young and elderly. So and then we compare using discriminant function analysis from the age around 75.86%. And when we compare, we found that there is a significantly there is a cross classification accuracy highest in youngest, between 70.7%, elderly 56.6%, while a middle age only 32.7% after cross validate. So the discriminant functions of the young, middle, and elderly is around 30 to 70%. When we compare with ancestry and sex is most highest is 80%, while the ancestry around 50 to 70%. So discussion, as we know, estimation of age in adult is challenging, as all of the bones were matured and stopped growing, thus being the focus of forensic research for several years. And especially if it include the legal issue, refugee issue, and it's a field of competitive sports. And the age difference, in this case, you can see towards the formation angle of the mandible. And the widest angles is in children, followed by old age, adolescent around 110. And future research is going to assist in forensic anthropologists in determining the skeletal age. In conclusion, this research prove that there were variation of mandible size and shape structure by across different age groups. And although actually the classification accuracy of age was only 54.6%, the result demonstrate that the potential mandible analysis as a valuable tool in age estimations. And the GM provide important options method to show the visualizations of the variation of mandible morphology, and the database of the age-specific mandibular landmark will be useful for future forensic investigation and contribute to age estimation technique for identification of unknown remains in forensic anthropology. So there's lots of things to do after this. Maybe we can move to AI to improve our research in forensic anthropology field to help its identification of the patient. So this is our project. So this is for example, this is unknown skeletal remains. So we run the CT scan, and then we compare with our database, and we run geometric morphometric analysis. And then we found that this unknown skeletal remains is a male Indians aged between 40 to 60 years old. So we won many innovation competitions awards, and we also present our project in the conference in the society. We organize a conference and in the society, as we are the leader of the geometric morphometric analysis in Malaysia. So we also went to Spain a few times to learn about the geometric morphometric analysis, and we sharing our knowledge to the university and any institution that invited us. We also share the knowledge into the book and mix with the religion, Islamic perspective in the book. And we go to the media, the radio stations to give sharing experience and knowledge of the bones of the forensics related to Islamic perspective to the society. So I hope you enjoy my presentation. This is my references. I would like to thanks to my supervisors, and also UKM Finding to find our project. And with man arada dunya fa alayhi bil ilmi, wa man arada al akhirah fa alayhi bil ilmin, wa man aradahuma fa alayhi bil ilm. Whoever wants dunya, they must have a ilmu, a knowledge, and who wants to akhirats, they needs a knowledge also. And whoever wants both, you need to know, you need to have a knowledge. So together we learn as much as we can, and then we share our knowledge, and we build up our nation, inshallah. Assalamualaikum warahmatullahi wabarakatuh.